Okay, 93, determine the coordinates of point of intersection. Basically, they're saying we have a system of equations and we want to know the point of intersection. So we could use equal value methods. So for A, there's our system of equations, right? So since they both equal y, then we know that 2x minus 3 has to equal 4x plus 1 because they're both equal to y. So now we could subtract 2x from both sides. We get negative 3 equals 2x plus 1. We could subtract 1 from both sides. Negative 4 equals 2x. Divide both sides by 2. And I'll come up here, right? And we get negative 2 equals x. So x equals negative 2. And we're not done, right? So we have x. Now we have to substitute. I'll substitute into this top one, right? So y equals 2x minus 3. Y equals 2 times negative 2 minus 3. Y equals negative 4 minus 3, y equals negative 7. So there's the two x and y. So to write it as an ordered pair, we would write negative 2, negative 7 as an ordered pair. And again, when I chose right here to use this equation to substitute in x, I could have used the bottom, either one, because these points have to work. This point has to work in both equations. Okay, let's do B now. Let me make some room. So B, very similar. We have a system, and we can use equal value methods. So I have 2x minus 5 equals negative 4x minus 2. We could add 4x to both sides, right? And we have 6x minus 5 equals negative 2. We can add 5 to both sides. 6x equals 3. Divide both sides by 6. And we get x equals 1/2, or 3/6, right? So we're halfway there. Now I need to choose an equation. I'm going to choose the top one because it doesn't have any negatives in there. And we'll substitute in. So we get y equals 2x minus 5. Y equals 2 times 1/2, right? We solved for x and got 1/2, minus 5. 2 times 1/2 is 1. So y equals negative 4, and now we write it as an ordered pair, xy, 1/2, negative 4, and that ordered pair will work in both of those equations. And if this were a test, you would take that and make sure it works in both the equations.